Hello everyone, we are Group 6 and we will be presenting our concept for our water filtering RoboCrab. For this presentation, we will go through the description of the project, the research and thinking we went through for our concept, and finally everything else about the project, such as the concept sketches, media we will use for our display, and the individual roles for our team members. First, let's review our project's description. So, what are we creating? As a group, we came together and thought about what kinds of technologies will be present in the future regarding water conservation. We thought that in the future, cleaning aquatic ecosystems will become a trend within humanity. So we wanted to create machines that would be very beneficial to the cleanliness of water, but without being too intrusive to the aquatic biome. We are thinking of creating robot sea creatures, such as one in the shape of a horseshoe crab, that help to filter plastics and microplastics in large bodies of water. By now, we should all be aware that ocean pollution is a continuously growing issue in the world, and it's affecting all of us. Tons of garbage are dumped into the ocean every day. There are now more plastics in the ocean than there are fish, and most of our garbage ends up on the ocean floor. Plastics are now more commonly found in the food chain and can enter our bodies through the fish we eat. Fashion also contributes widely to plastic pollution. It is estimated that 4 billion per square kilometers of microfibers are in the ocean. Continuing on with our research, we looked at how water is being filtered in nature. Water filter feeding is one of the most common ways of how aquatic animals eat. Clams, sponges, krill, baleen whales, and some fishes are aquatic creatures that use filter feeding in their lives. Filter feeding animals are what balances out the ecosystem. They make sure that bad bacteria and toxins are being removed to ensure the health of the ocean. This is our goal with our water filtering crabs. We want them to remove plastic pollutants from large bodies of water to improve the well-being of the aquatic environment and everything else that relies on it.
Next, we'll go over how the RoboCrab works, accompanied by sketches of the design, then followed by the team roles.
Inspired by nature's efficiency, the RoboCrab mimics the crab's agile movements, ensuring it can traverse the ocean's floors with ease. Its intelligent sensors detect and locate microplastics with remarkable precision. RoboCrab efficiently captures microplastics of all sizes, scooping up the pollutants but ensuring minimal disturbance to marine life. The collected microplastics are then processed with the robot's onboard recycling unit. Utilizing cutting-edge technology, the RoboCrab separates the plastics from the water, turning the waste into recyclable materials. This specific design is inspired by the horseshoe crab silhouette. Its metallic shell is adorned with two LED eyes that glow brightly, giving it almost a lifelike appearance. As RoboCrab moves along the floor, its tail sways, collecting bigger trash like nets and plastic bottles and preventing them from causing further harm to our delicate marine ecosystems. RoboCrab operates autonomously, but can also be controlled remotely and sent to specific directions by its two wheels that come on each side.
Now, getting into the process of how we conclude with this design, we started creating a conceptual shape of what we wanted it to look like, taking inspiration from our research. We first created a shape which followed in a very basic way the shape of a horseshoe crab and kept making it look more organic. During this process, we thought of the dynamic and functionality we'll have, taking in consideration the system that will go inside. We ended taking the last conceptual model into another process of how to make it look and work better, deciding to put on a coverage structure following the shell composition of C that the horseshoe crabs have. This would give it a better mobility and protection. And here is the conceptual result of it.
I will introduce the medium we use for our project. For the robot part, we will model a one-on-one huge crab shell and some small crab shells and then 3D print it. We will use Arduino to motorize it so that it can move. In the projection part, we will use Touch Designer to create scenes similar to the ocean. For moving the robot, we will also use Arduino so that the user can control the robot with a joystick. On the top right, there is a picture showing what it will look like. On the bottom is our reference idea for a projector game. When people move, the projection scenes will change. Here are our individual roles for each group member. Nora is our project manager and she will be the main speaker and document editor. She will also do research work and overall support and help. For me, Sherry, I will be working on Touch Designer and Arduino design. Also, I will be working on document creation. Irina will be our video editor and she will also work on Arduino and programming, 3D modeling, and any physical requirements. Verónica will work on 3D modeling and concept sketches. Anahi will be the concept artist to do some sketches.
Thank you for listening.